So by now we should be able to differentiate most easy basic functions, and also using this find the gradients and find the lines of the tangent and the normal. But the good thing about the derivative is that we can also determine whether a function is an increasing function or a decreasing function. This we do by saying that within a certain interval a to b, let's say, if the dy by dx is less than or equal to 0, then we say it's a decreasing function. If it's bigger than or equal to 0, we say it's an increasing function. You can imagine this on a graph. So let's say I have an x squared graph like this, right? Just imagine as you follow the line, if it's moving downwards, then we can imagine it as a decreasing function because it's got a negative gradient. If the graph starts moving upwards, then you can say that it's an increasing part of the function because we have a positive gradient going upwards. Let's look at this graph here, and what we want to do is identify the increasing parts of the function and the decreasing parts of the function. So we're given these 2 points here, x is -1 and 1, and these are known as stationary points. We'll look at this in more detail in the next videos. But importantly, we have to identify where is the function decreasing. We can do this by following the graph, and imagine if you're following it and you're moving in a downwards motion, it means it's a decreasing part, and if you're moving in an upwards motion, it means you're in an increasing part. So for any value x is less than -1, you can see that the graph is moving downwards, right? So that means it's going to be a decreasing portion. Past x is -1, we start moving upwards, the graph starts moving back upwards, and so this part here is an increasing function until it reaches this x is 0. So between -1 and 0, we can say that the function is an increasing portion. Past x is 0, we start moving back downwards again, right? So this portion here is a decreasing part. And then when x is larger than 1, we start moving back upwards, so it's an increasing part. So we go from decreasing to increasing to decreasing to increasing. So let's look at an example. So let's say we have the function f of x is 3x squared plus 8x plus 2. And they're asking us to find the increasing part of that function. Well, first things first, we differentiate to get f prime of x is equal to 6x plus 8. We now make this bigger than or equal to 0 because we're trying to find the increasing part of this function, right? And solve for x. So it means we get x is larger than or equal to -4/3. So that shows us that any values of x larger than or equal to -4/3 will be an increasing part of that function. Let's try another one. So let's say we have the function g of x is equal to 2x cubed minus 15x squared plus 36x. This time let's try and find the decreasing part of that function. So we can now differentiate first, so to get g prime of x, which would give me 6x squared minus 30x plus 36. This time it's going to be less than or equal to 0 because we want to find the decreasing part. Solving for x, we get x minus 2 in brackets, x minus 3 is less than or equal to 0. So the interval is going to be between larger than or equal to 2 and less than or equal to 3. So this portion, that portion of the graph will be when the function is decreasing. We can actually see this in the graph if we were to sketch it. So let's sketch the g of x graph, and you can see in the portion between 2 and 3 that the graph is moving downwards, which makes sense, right? Let's try one final one. So for this function, let's show that it's always going to be decreasing, okay? So first things first, differentiate it again. F prime of x is minus 6x squared minus 3. Now we need to show that it's always going to be decreasing. I is always going to be a negative number, right? So I'm going to factorize it by taking out minus 3. So I get minus 3 in brackets 2x squared plus 1. Now, this is always going to be a negative number, right? Because 2x squared plus 1 is always going to give you a positive number, and then the minus 3 will then change it to a negative number. So therefore, meaning that for whatever x value is always going to be a decreasing function.